I'm going to introduce to you federated learning, which is a powerful solution if you want to build machine learning models from diverse sources of data and while protecting the privacy of the data, which is something that is, of course, very important as we deal with medical data. So I'm sure that you are all familiar with the fact that in order to build an efficient and robust machine learning model, you need to consider a lot of data. And if for some cases, it's really good to be able to consider data from diverse sources, For instance, you mentioned, in the introduction before, we had the example of the COVID situation. It would have been great to be able to leverage data from several hospitals in order to build efficient machine learning models. The problem is that in healthcare, we'll deal with sensitive data. And so it's not always possible to pool and gather all the data in one server, so the data from these diverse sources of data, and train a machine learning model there. Indeed, we deal with sensitive data, so either because it's personal data, so some medical records, for instance, but also if it's competitive data, such as drug discovery data. So those are not personal data, but still they are very sensitive because they contain a lot of competitive value. And also in some cases, it's not possible to pull the data in one server, so the data from these diverse sources, just because it's complex and it costs a lot of money to move the data. And so here appears federated learning, which is this powerful technique which makes it possible to still train a machine learning model while keeping the data stored in the different centers. So more specifically, so here on this animated image, you see 3 centers, so A, B, and C. So in each of them, there is data. And you want to train the machine learning model, which is represented with this type of atom, and which goes in the different centers, is trained on the data, and then sent back to another server, which is called here the averaging server, in order to be aggregated. And we repeat this operation many, many times in order to train the machine learning model while keeping the data stored in the different centers. And by doing so, the performance of the model is increased because it's possible to leverage data from these multiple sources. Still, we protect the privacy of the data. So because the data are kept stored in the server, but also because we can use privacy enhancing techniques, which I'm going to talk about later. And the centers can keep the control over their data. So they keep the data, so it's easier to know what is done with their data. So I work for Owkin, which is a startup doing machine learning in order to help the medical research. Basically, we try to create knowledge from medical data. And so very soon we realized that we had to leverage data from multiple sources if we wanted to be able to build very efficient and robust model. And so this is why we have built this product, so this federated learning platform, which is called Connect. And Connect is an end-to-end platform for federated learning, which is built around 3 key pillars. So the first one is collaboration, because it makes it possible to collaborate between different centers, medical centers, and also it enables collaboration between data scientists and data owner, collaboration which would not be possible in the cases where we cannot share the data. The second pillar is compliance. We use federated learning and we use it in a traceable way. We trace all the operations that are done with the data, which makes it possible to keep the control over the data and make sure that the data are used for the right reason. And so still be compliant with the different regulations. And the third pillar is confidentiality, because we keep the privacy of the data. So the data remains stored on the server of their owner. And also we use privacy enhancing technique, such as the secure aggregation or differential privacy. And these privacy enhancing techniques are very important in order to make sure that the model that travels from one center to another cannot leak any properties of the data. So I have no time to go into the details of these two techniques, but if you have any question, I would be happy to answer them in the Q&A. In order to do federated learning, you need to have different layers in your technical solution. So of course, you need compute resources. And so you need storage for the data, and you need CPU and GPU power in order to do the computations. And this can be either on the cloud, or on-prem. Then in the case of our solution, you need something to orchestrate the containers, because our solution is deployed on a Kubernetes cluster, which makes it possible to deploy both on-prem or in the cloud, and also to leverage the power of the cloud. If you want to be able to use much more resources, it's possible using Kubernetes. Then you need to have something to exchange model, some networking solutions, because the model are going to travel from one center to another, and you need to make it in a very secure way. Of course, you need something to manage data, the algorithm, and the training of the model. So, and if you want to specify some permission on your data on the algorithm, you need to have a permission management. And in order to orchestrate the training of a model on diverse sources of data, you need to have something that orchestrates the computation. And so this is what is done in Substra, which is an open source solution, which is developed by Owkin, and which is at the core of Owkin Connect, our solution. Then, in order to be able to train your machine learning model with federated learning schemes, so meaning how to train it, in which with which are you going to use federated averaging or federated GD or FedProx, which are all different schemes to be algorithms to train your machine learning model and exchange gradients and aggregate them in a way that leads to good results. And so these federated learning schemes, there are multiple of them, and you need to choose the ones that correspond to your data and your problem in order to build an efficient model. And this is what we have created in our library for data scientists, so that they can choose which schemes they want to use to train the model. And finally, there is a monitoring solution. So it's a graphical interface in order to be able to monitor the computations and visualize the performances of the model. And so this is all these layers correspond to Owkin Connect, so this software product. And then on top of it, you need to have some machine learning or statistical algorithm if you want to do federated queries in order to train your final model. And so this stack, we deploy it in each center. So if you want to enable federated learning, you need to deploy the whole stack in each of the center. And so it can be deployed on the cloud and on-prem. Once it's deployed, of course, you want to use it. So the first step is to register the data. So in order to register the data, you can directly register it into the software, or we can build some specific connectors connectors with specific databases. So the challenge is not to register the data. The challenge is really to prepare the data in order to them to be registered, because you need to make sure that the data are harmonized between the different centers. And this is a challenging step, and something that for now it's very difficult to automate. You need to find some harmonization solution which are specific for each type of data and each problem. And so you can use, it's possible to use multimodal data. So it's pretty flexible for that. Then the second step is to design an algorithm and a compute plan. So a compute plan is this sequence of training and aggregation and evaluation steps, so corresponding to this federated learning scheme. So it's really the specification on how you're going to train your algorithm on the data. And so in Connect, so it's very flexible for the training algorithm. What you need to specify is limited by specific input and output of the algorithm. So basically, you have in input some data, X and Y, and the output is a model or gradients or model updates. And here the challenge to design this algorithm is to design it while keeping the privacy of the data. And here it depends on the privacy level of your data. So for instance, for some use cases at Owkin, we have access to part of the data with remote access. So we are able to explore the data and design the algorithm using this subset of accessible data. But in other cases, and such, for example, the ones that I'm going to talk about later, we don't have any access to the data. And here, the solution is to work with open data that are very similar to the real data. But it's something that is, I mean, difficult to do, and that is an important point for federated learning. And so once you've registered your data, your algorithm, and the compute plan, the training starts automatically within the platform as specified in the compute plan, and your model is trained. Okay. Now that we've seen what federated learning is and how we can enable it using Connect, so I would like to talk about a very interesting project, which is the MELODY project. So the objective of the MELODY project is to use federated learning for drug discovery. More specifically, we work with 10 pharmaceutical companies along with other solution partners in order to create a platform, end-to-end platform, so meaning not only the software, but also the data preparation, the deployment, which is done on AWS, the data preparation and the design of the algorithm. And in order to be able to leverage drug discovery data from these 10 pharmaceutical companies, to build a machine learning model out of it and try to assess whether this federated learning model leads to better performances compared to a model which would have been trained on the data of one pharma partner only. So it's a project which is funded by the European Commission. So it's an IMI project, which started 2 years ago. And along, so we work with these 10 pharmaceutical companies and as well as with solution partners. So there are some partners who are responsible for setting up a Kubernetes cluster on AWS. So those are Kubernetes, with the help of NVIDIA. Then at Owkin and along with Substra, which is a foundation, which was a hosting bit for the open source code Substrat developed by Owkin. We build the software in order to do federated learning. And then the other partners, so BME, Ictos, and K11, they work on the algorithm, which is not an easy task because in the case of Melody, as you can imagine, the data is very sensitive. It's drug discovery data. So we do not have access to any data, even to design the algorithm. We work with an open source dataset, Campbell, but still, so it's a challenging task. The project started, and data preprocessing is also a challenging task. So I'm running a bit out of time, but very briefly, in the case of Melody, there is a full work package which is dedicated to preparing the data. It's a vertically partitioned federated learning because the data is not exactly the same for the different partners, and especially they have different labels and different assays. And so we use a specific type of model with a common trunk, which is the same for all the different partners, and a specific head model, which is specific for each pharma and which remains private for each pharma. And it's a 3-year project. We are at the end of the 2nd year project, so we should make an announcement very soon at the end of September. So stay tuned if you want to know what were the results of the 2nd year. So thanks a lot for your attention, and now I would be happy to answer to any question.
Thank you, Camille. It's a really interesting talk. We have a couple of questions. So the first one is on, I guess it's on culture. So it's talking about there's a precedence at the moment to centralize data, to put data into a data lake. Do you have any kind of efforts to try and change the culture, to try to like put forward a case for keeping the data where it is federated and then dealing with the complexities, but also I guess the privacy benefits of using this kind of federated approach? Could you just talk about the culture there? Are there any cultural problems that you have to face?
Yeah, sure. So in terms of culture, what we observe is that it's very different between the US and Europe, and also Asia, of course. So in Europe, federated learning appears as, something that is very important to have, because data privacy is something that is put, at the top of the priority, and especially, with the GDPR or with other types of initiative, we can observe that it's not going to be possible to gather all the data of the different hospitals in one place, and also because of the nature of how the healthcare system is organized in Europe. We have different healthcare systems, and it's just a no-go to centralize all the data. Whereas in the US, it seems to be a bit different. And in particular, hospitals tend to be maybe more okay to build data lakes. But what we observe in Europe, and in France or in the UK as well, they are starting a big federated learning project. It's something that is not going to be possible.
Yeah, it's a real challenge. It's a really important topic as well. Another question, and it's related to this, and it's to do with if the data has privacy or there's restrictions in terms of even sharing small amounts of data. Have you thought about any approaches, or do you have any kind of solutions for initial prototyping of algorithms so that we know how to actually implement the algorithm? Does it work prior to performing the federated learning? Do you think about solutions such as anonymization or synthetic data?
Yeah, so synthetic data is something that could, so anonymization, in most cases, we have to anonymize data before being able to work with them. And synthetic data, it's also a way to be able to build some subset of data to prototype your algorithm. And but still, it's not an easy task to build a synthetic data. But of course, it's the way to go. I mean, to make federated learning an efficient solution. Because if you cannot see the data, then it's very difficult to build efficient model. So yes, I mean, being able to have synthetic data, or in some cases, access to a subset of really anonymized data, or working with very similar data, are ways to be able to prototype your algorithm, iterate with it.